Parallel operation of transformer. A parallel operation transformer is used for industries or for large power plants. We are using large load. So large load sharing is done by using parallel operation of transformers. The necessary conditions of transformers should be there is two transformers which is connected to parallel. Their each windings will be connected to supply side and load side. Both are parallel. So their polarity should be same. The kVA rating should be same. The turns ratio of each transformer should be same, and the internal resistance to reactance ratio should be same. So these are the necessary conditions of the transformer which is connected to parallel in industry. Now we will see the circuit diagram of parallel operation of transformer. So in parallel operation, that both transformers primary winding is connected to supply side and the secondary winding connected to common load side. So here we can see there is two transformers. Impedance of first transformer is ZA, and there's another transformer B, we can say. The impedance of transformer B is ZB. The current in transformer B is IB, load side current. This current will be IA. So this is the load, and that load is common load. So these two windings of two transformers secondary side is connected to common load. That point is P. Similarly, this is connected to the supply side. V1. So here we can see the two transformer A, transformer B, their primary windings are both connected to the common supply side, and there is a two current in IA and IB, both are connected to the load current, that is IL. So this is the impedance of transformer A, this is the impedance of transformer B, and both secondary winding is connected to the common load side, and that load voltage is VL. So if we apply the KCL at point P, we will find out the IL is equal to IA plus IB. IA plus IB, and IL is the load current. So this is the equation 1. So we know that IL is equal to IA plus IB. This is our first equation. So KV, if we apply KVL at transformer at load side, if apply KVL apply at load side in transformer A, so we'll find out VL is equal to V1 upon K1 minus IA into ZA, and Kevin is a turns ratio. Similarly, at transformer B, we can apply the KVL. We will find out at transformer B, we can find out VL is equal to V1 by K2 minus IB into ZB. So from equation 1 we can find out the value of IB, and when put in equation 3 we can find out here IB is equal to, we know IB is equal to IL minus IA. So this IB value we can put in this equation 3. So we'll find out here VL is equal to V1 by K2 minus IL minus IA into ZB. This is fifth equation. Because these are the parallel transformers, so their K1 and K2 will be equal. K1 is equal to equal because is a condition. So we can find out here there is two equations. This equation will be VL is equal to V1 upon K1 minus IA ZA, and this equation is VL is equal to V1 K2. So we can equal the equation 2 and equation 5. So we can find out here V1 upon K1 or K1 K2 is equal. So V1 upon K1 minus IA ZA is equal to V1 upon K1 minus IL minus IA into ZB. We can equalize, we can find out here, this will be cancel. So we can find out here, we can rearrange. So minus IA ZA is equal to minus IL ZB plus IA ZB. So we can substitute here. So we can find out here equation will be like this. IA is equal to IL ZB. So from that we can find out here IA is equal to IL into ZB divided by ZA plus ZB. This is the load current of transformer A. The sharing of the load will be IL into ZB upon ZA plus ZB. Similarly, we can find out the load current at transformer B will be equal to IL ZA upon ZA plus ZB. So when we divide both, we will find out here the ratio of load current of IA upon IB is inversely proportional to the impedance. This equation. So this is the equation number 6, this is 7, this is 8. So load sharing will be there, but load share will be the inversely proportional to the impedance. So if we multiply by the load voltage to the each current of transformer, so we'll find out load VA. So load voltage ampere, that is we can represent as by SL, and that is equal to VL into IL. Similarly, the VA of transformer A, VA in transformer A, we can write here SA is equal to VL into IA. Similarly, SB is equal to in transformer B, VL into IB. So if we multiply by VL in both sides of equation 6 and 7, we will find out SA is equal to SA is equal to SL into ZB upon ZA plus ZB. Similarly, we can find out SB is equal to SL into ZA upon ZA plus ZB. Again, we will find out here SA upon SB is equal to ZB upon ZA. So load sharing is inversely proportional to the impedance. So these equations will help to find out the value of the load VA, transformer A VA, transformer B VA rating, and also we can find out the how much load is shared by the each transformer. Thank you very much.